To determine if you need to add another electrical panel, you'll need to calculate the full load current, or FLC, of your existing panel. The formula for this is full load current equals total wattage divided by voltage. Total wattage is the sum of the wattage of all electrical devices and appliances connected to the panel. Voltage is the voltage of the electrical system, typically 120 or 240 volts in residential applications. Here are the steps to calculate the full load current of your electrical panel. Firstly, identify all electrical devices and appliances connected to the panel. This includes lighting, outlets, appliances, and any permanently connected equipment. Secondly, determine the wattage of each device. This information can usually be found on the device's nameplate or in its user manual. Look for a label that specifies the power consumption in watts. Thirdly, calculate the total wattage by adding up the wattage of all the devices and appliances connected to the panel. Make sure you account for every load that's connected. Fourthly, divide the total wattage by the voltage of your electrical system. In North America, this is typically 120 volts for standard outlets and lighting, or 240 volts for larger appliances like ovens and dryers. The result of this division will give you the full load current in amps. For example, consider a panel with the following devices connected: 5 lights at 60 watts each, which equals 300 watts, 10 outlets at 150 watts each, which equals 1500 watts, 1 refrigerator at 300 watts, 1 microwave at 1200 watts, and 1 oven at 2500 watts. To calculate the total wattage, add the wattage of all the devices: 300 plus 1500 plus 300 plus 1200 plus 2500, which equals 5800 watts. Assuming the voltage is 120 volts, the full load current is calculated by dividing the total wattage by the voltage: 5800 watts divided by 120 volts, which equals 48.33 amps. This means that under full load, the devices connected to the panel will draw 48.33 amps. Once you've calculated the full load current, you need to compare this value to the maximum amperage rating of your panel. This rating is typically found in the panel's main breaker. If the full load current exceeds the panel's rating, it indicates that the panel is overloaded. An overloaded panel can lead to overheating, trip breakers, and potentially dangerous situations, including electrical fires. If the full load current exceeds the panel's rating, you have a few options. Firstly, you can install a higher rated panel to accommodate the increased load. This involves replacing the existing panel with one that has a higher amperage capacity. Secondly, you can add subpanels to distribute the load. This involves installing additional panels to which you can connect some of the circuits from the overloaded panel. This helps to distribute the load more evenly and prevent overloading. It's also important to consider demand factors when calculating the full load current. Demand factors are used to account for the fact that not all devices will be operating at their maximum wattage simultaneously. For example, you might not use all the outlets at the same time, or you might not use the oven and microwave at the same time. Demand factors can be applied to reduce the calculated full load current, but it's important to use them cautiously and only when you have a clear understanding of how the devices will be used. When working with electrical systems, it's always important to prioritize safety. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the calculations and any necessary upgrades. Incorrect calculations or improper installation can lead to serious safety hazards. Always turn off the power to the panel before working on it, and use appropriate safety equipment, such as insulated gloves and eye protection. In addition to calculating the full load current, it's also important to consider the National Electrical Code, or NEC, requirements for panel sizing and load calculations. The NEC provides detailed guidelines for determining the appropriate size of electrical panels and the maximum allowable load. These guidelines are based on safety considerations and are designed to prevent overloading and other electrical hazards. It is crucial to consult the latest edition of the NEC and follow its requirements when sizing electrical panels and calculating loads. The NEC provides tables and formulas for determining the minimum size of conductors, overcurrent protection devices, and electrical panels based on the connected load. Understanding and applying these requirements is essential for ensuring the safety and reliability of electrical systems. Some specific NEC articles that are relevant to panel sizing and load calculations include Article 220, which covers branch circuit, feeder, and service calculations, and Article 310, which covers conductors for general wiring. These articles provide detailed guidance on how to calculate the load on various types of circuits and how to select the appropriate size of conductors and overcurrent protection devices. In addition to the NEC requirements, it's also important to consider any local codes or regulations that may be in effect. Local codes may have additional requirements or restrictions that must be followed. It's always a good idea to check with your local building department or electrical inspector to ensure that your electrical work complies with all applicable codes and regulations. When calculating the full load current, it's important to be accurate and thorough. Make sure you account for all the devices and appliances connected to the panel and use the correct wattage ratings. If you are unsure about the wattage rating of a particular device, it's always better to err on the side of caution and use a higher value. Inaccurate calculations can lead to overloading and other electrical hazards. It's also important to consider future load growth when sizing electrical panels. If you anticipate adding more devices or appliances in the future, it's a good idea to choose a panel that has sufficient capacity to accommodate the increased load. This will help to avoid the need to replace the panel in the future. When selecting a new electrical panel, there are several factors to consider. Firstly, the amperage rating, which should be sufficient to handle the calculated full load current and any future load growth. Secondly, the number of circuit breakers, which should be adequate to accommodate all the circuits in your home. Thirdly, the type of panel, which can be either a main breaker panel or a sub-panel. Main breaker panels are typically used as the main service entrance panel, while sub-panels are used to distribute power to specific areas of the home. Fourthly, the quality and reliability of the panel, which can vary depending on the manufacturer and model. It's always a good idea to choose a panel from a reputable manufacturer with a good track record. When installing a new electrical panel, it's important to follow the manufacturer's instructions carefully. The instructions will provide detailed guidance on how to install the panel safely and correctly. It's also important to ensure that the panel is properly grounded and bonded to prevent electrical shock hazard. Grounding and bonding are essential for providing a safe path for fault current to flow back to the source, which will trip the circuit breaker and energize the circuit. In addition to grounding and bonding, it's also important to install surge protection devices to protect your electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protection devices can help to protect your equipment from these surges and extend their lifespan. There are several types of surge protection devices available, including whole house surge protectors and point-of-view surge protectors. Whole house surge protectors are installed at the main electrical panel and protect all the circuits in the home. Point-of-view surge protectors are plugged into individual outlets and protect the equipment that's plugged into those outlets. When choosing surge protection devices, it's important to select devices that are rated for the appropriate voltage and current levels. It's also important to choose devices that have a good track record of performance and reliability. In addition to the safety aspects of electrical panel sizing and load calculations, there are also energy efficiency considerations. Choosing the right size of electrical panel can help to improve energy efficiency and reduce energy costs. For example, if you choose a panel that's too large, it can result in increased energy losses due to the increased resistance of the conductors. On the other hand, if you choose a panel that's too small, it can result in overloading and reduced performance of your electrical equipment. Choosing the right size of electrical panel can help to optimize energy efficiency and reduce energy costs. In conclusion, calculating the full load current of an electrical panel is an important step in determining whether the panel is adequate for the connected load. By following the steps outlined in this video and consulting the NEC requirements, you can ensure that your electrical panel is properly sized and that your electrical system is safe and reliable. Remember to always prioritize safety when working with electricity, and if you're not comfortable performing the calculations or installations yourself, it's best to hire a qualified electrician. By taking these precautions, you can help to protect yourself and your family from electrical hazards and ensure that your electrical system operates safely and efficiently. This information is for educational purposes only and is not a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.